Students, welcome to the class. In today's lecture, I am going to discuss about RSA encryption in discrete mathematics. Here, that is mainly used in discrete mathematics. Here in our modular mathematics topic, we have a RSA algorithm. Okay. Now, RSA basically it stands for three scientists who built this. RSA means Rivset, Shamir, and Edelman. In the name of them, in short, they have mentioned it as RSA. It can be described as an encryption algorithm. It is basically it's an algorithm, okay, where it is used to securely transfer the message with the help of internet. The principle behind this algorithm is what? It we can easily multiply large amount of numbers, but it will be difficult to factor the large numbers. So it can easily multiply large numbers, but we can't factorize so easily. Okay, for example, if we multiply 31 and 37, we can easily get the result. Okay, but in the reverse process, if we determine the factorial of 1147, it will be a little bit tough. Okay, so in this algorithm, they have mentioned some keys. Okay, it is basically comes under the topic cryptography. Okay, that is the main area in network security. So, two different kinds of cryptography systems are there. First one is private, that is a secret key cryptography. Private or secret means what? Secret andre we can't share with anyone. Okay, it is a private. Public key cryptography. Public key means what? It will be used by all. Okay, it is open, we can't hide this. This is a public key. Private key is what? It is concerned with only whoever concerned with that uh, key, only they can handle that. Okay, so in private key cryptography, sender and receiver agree on secret key that both used to encrypt or decrypt the message. So ಪ್ರೈವೇಟ್ ಕೀ ಕ್ರಿಪ್ಟೋಗ್ರಫಿ ಒಳಗೆ ಏನಿರುತ್ತೆ ಅಂದ್ರೆ ನೀವು ಯಾರಿಗೆ ಮೆಸೇಜ್ ಕಳಿಸ್ತೀರಿ ಮತ್ತೆ ಯಾರು ಮೆಸೇಜ್ ಅನ್ನ ತಗೊಳ್ತಾರ ಅವರಿಬ್ಬರು ನಡುವೆ ಮಿಡ್ಲು ಏನಿರುತ್ತೆ ಒಂದು ಅಗ್ರಿಮೆಂಟ್ ಇರುತ್ತೆ. ಏನು ದೇ ಕ್ಯಾನ್ ಎನ್ಕ್ರಿಪ್ಟ್ ಆರ್ ಡಿಕ್ರಿಪ್ಟ್. ಎನ್ಕ್ರಿಪ್ಟ್ ಮಾಡಿದ್ರೆ ಕಳಿಸಬಹುದು, ಕೋಡಿಂಗ್ ಮಾಡಿ ಕಳಿಸಬಹುದು, ಅದನ್ನ ಡಿಕೋಡ್ ಮಾಡಿ ಅವರು ರಿಸೀವ್ ಮಾಡಬಹುದು. ದಟ್ ಈಸ್ ವಾಟ್. ಸೊ ಇನ್ ಪಬ್ಲಿಕ್ ಕೀ ಕ್ರಿಪ್ಟೋಗ್ರಫಿ ಒಳಗೆ ಏನಿರ್ತದೆ, the key is used to encrypt the message and the private key is used to decrypt the message. What is the difference? Public key na encrypt ಮಾಡ್ತೀವಿ ಮೆಸೇಜ್ ನ, private key ಮೆಸೇಜ್ ನ ನಾವು ಡಿಕ್ರಿಪ್ಟ್ ಮಾಡ್ತೀವಿ. Modern systems use public key crypto. Best known public encryption algorithm is RSA algorithm. So for basically RSA algorithm is what? It is a public key encryption. So it is used for this. Means RSA is a algorithm is a part of your cryptography. In this we are using this for public key encryption. Okay. Basically it is called as asymmetric cryptographic algorithm. Asymmetric cryptographic algorithm means what? It has two keys, that is public and private. Okay. The RSA is totally based on the number theory. The RSA can be used in file encryption, secure shell. Where you are going to use this RSA? Why we need to study? Because it has application in file encryption, secure shell or FTP, sending information of credit card, debit card, saving passwords, encrypting emails, and many more. In all these, whatever network related you are going to, you are in a real life you are facing, in all these you are going to use, you are using this RSA. Okay. For example, the message we are trying to send the owner can be encrypted by anyone with the help of a public key, but it can be decrypted only by the owner with the help of a private key. Okay, ಈಗ ಯಾರೋ ಒಬ್ಬರಿಗೆ ನೀವು ಓನರಿಗೆ ಮೆಸೇಜ್ ಕಳಿಸ್ಬೇಕು ಅಂದ್ರೆ ಪಬ್ಲಿಕ್ ಕೀ ಯೂಸ್ ಮಾಡಿ ನೀವು ಅದನ್ನ ಎನ್ಕ್ರಿಪ್ಟ್ ಮಾಡಿ ಕಳಿಸಬಹುದು, ಬಟ್ ಅದನ್ನ ಡಿಕ್ರಿಪ್ಟ್ ಮಾಡೋ ಕೆಪಾಸಿಟಿ key only owner ಹತ್ರ ಇರುತ್ತದೆ, because he has a private key. It shows like we have a private lock box that contains a slot for the message. There can be an opposite case where the owner encrypts the message with the help of their private key and anyone has the ability to decrypt it. But in this case, only the owner can encrypt the message. Reverse case irutte, ಅವರು encrypt ಮಾಡಬೇಕು ಅಂದ್ರೆ private key ಇಂದ encrypt ಮಾಡಿದ್ರೆ only they have a option to encrypt the message. But decryption public key ಇಂದ ಮಾಡಬೇಕು. So now, what is the maths behind this RSA? As I mentioned, maths behind RSA is purely number theory, because here for private key we have to choose large prime numbers. Okay, public key consists of number n, which is a product of p and q. Okay, another number e we are going to use, that is relatively prime with your n. So ಇಲ್ಲಿ ಏನು ನಾವು ಕೀನ ಯೂಸ್ ಮಾಡ್ತೀವಿ, ಅವೆಲ್ಲವು ಕೀಗಳು ಅವೆಲ್ಲವು ದೇ ಆರ್ prime numbers, and they are relatively prime to each other. ಯಾವ ನಂಬರ್ ಟೋಷನ್ ಫಂಕ್ಷನ್, ಇಲ್ಲಿ ನಾವು ಟೋಷನ್ ಫಂಕ್ಷನ್ ಯೂಸ್ ಮಾಡ್ತೀವಿ. ಟೋಷನ್ ಫಂಕ್ಷನ್ ಏನು, ಇಟ್ ಗಿವ್ಸ್ ಫಾರ್ ಆಲ್ ಇಂಟಿಜರ್ಸ್ ಪಾಸಿಟಿವ್ ಇಂಟಿಜರ್ಸ್. ಓಕೆ, ಆಮೇಲೆ ಅಲ್ಲಿ ಏನಿರ್ತಾವ ರಿಲೇಟಿವ್ಲಿ ಪ್ರೈಮ್ ಇರ್ತಾವ. ಸೊ ಎನ್ಕ್ರಿಪ್ಟ್ ಮೆಸೇಜ್ ಎನ್ಕ್ರಿಪ್ಟ್ ಮಾಡಕ್ಕೆ ಏನಿರುತ್ತೆ ಎನ್ ಮತ್ತೆ ಇ, ಬಟ್ ಡಿಕ್ರಿಪ್ಟ್ ಮಾಡಕ್ಕೆ ನಾವೇನ್ ವಿ ಶುಡ್ ನೋ ದ ಲಾರ್ಜ್ ಪ್ರೈಮ್ ನಂಬರ್ಸ್. ಸೊ in the theory we can extract p and q by from n using prime factorization. ಪ್ರೈಮ್ ಫ್ಯಾಕ್ಟರೈಸೇಷನ್ ಮೆಥಡ್ ಯೂಸ್ ಮಾಡಿ ನಾವು ಪಿ ಅಂಡ್ ಕ್ಯೂ ನ ಯೂಸ್ ಮಾಡಿ ಎನ್ ಅನ್ನು ಮಾಡಬಹುದು. ಬಟ್ ದಿಸ್ ಈಸ್ ಇಂಟ್ರಾಕ್ಟೇಬಲ್ ಫಾರ್ ವೆರಿ ಲಾರ್ಜ್ ನಂಬರ್ಸ್. ಸೆಕ್ಯೂರಿಟಿ ಆಫ್ RSA ರಿಲೀಸ್ ಆನ್ ಇನ್ಹರೆಂಟ್ ಕಂಪ್ಯೂಟೇಷನಲ್ ಡಿಫಿಕಲ್ಟಿ ಆಫ್ ಪ್ರೈಮ್ ಫ್ಯಾಕ್ಟರೈಸೇಷನ್. ಸಣ್ಣ ಪುಟ್ಟ ನಂಬರ್ಸ್ ಗೆ ನೀವು ಪ್ರೈಮ್ ಫ್ಯಾಕ್ಟರೈಸೇಷನ್ ಯೂಸ್ ಮಾಡಿ ನಂಬರ್ ಅನ್ನ ವ್ಯಾಲ್ಯೂನ ಫೈಂಡ್ ಔಟ್ ಮಾಡಬಹುದು. ಬಟ್ ಕೆಲವೊಂದು ನಂಬರ್ಸ್ ವಿ ಕಾಂಟ್ do prime factorization. In such cases we are going to use this RSA. Okay. Now there are steps how to generate RSA keys. RSA keys ಅನ್ನ ಹೇಗೆ ಜನರೇಟ್ ಮಾಡಬೇಕು? We have to follow some steps. Okay. First one is we have to choose two large prime numbers p and q. ನೆಕ್ಸ್ಟ್ ಸ್ಟೆಪ್ ಅಲ್ಲಿ ಏನ್ ಮಾಡ್ಬೇಕು, ಆ ಪಿ ಅಂಡ್ ಕ್ಯೂ ನ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡ್ಬೇಕು. ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿದಂತ ವ್ಯಾಲ್ಯೂಗೆ ನಾವೇನಂತ ಕರಿತೀವಿ, ಎನ್ ಅಂತ ಕರಿತೀವಿ. ಓಕೆ, ಪಿ ಅಂಡ್ ಕ್ಯೂ ಇಸ್ ವಾಟ್, ಎನ್ ಇಸ್ ಪಿ ಇಂಟು ಕ್ಯೂ. After computing n, we have to calculate totient function, that is phi of n. Phi of n ಯಾಕೆ ನಮಗೆ ನಾನು ಪ್ರೀವಿಯಸ್ ಕ್ಲಾಸ್ ಅಲ್ಲಿ ಹೇಳಿದೆ ವಿಡಿಯೋದಲ್ಲಿ, totient function ನಮಗೆ we must know to study Euler's theorem as well as RSA algorithm. ಸೊ ಇಲ್ಲಿ ನೋಡ್ರಿ ಟೋಷನ್ ಫಂಕ್ಷನ್ ಯೂಸ್ ಮಾಡ್ತಾರೆ. ಸೊ ಟೋಷನ್ ಫಂಕ್ಷನ್ ಏನು, ಇಟ್ ಈಸ್ ಪ್ರಾಡಕ್ಟ್ ಆಫ್ p minus 1 and q minus 1. ಓಕೆ, ಒನ್ಸ್ ಯು ಫೈಂಡ್ ದಿಸ್ ಟೋಷನ್ ಫಂಕ್ಷನ್, ನೆಕ್ಸ್ಟ್ ಸ್ಟೆಪ್ ಅಲ್ಲಿ ಏನು, ವಿ ಹ್ಯಾವ್ ಟು ಚೂಸ್ ದ ವ್ಯಾಲ್ಯೂ ಆಫ್ ಇ. ಯಾವ ಟೈಪ್ ವ್ಯಾಲ್ಯೂ ಚೂಸ್ ಮಾಡಬೇಕು ಹೀಗೆ ಅಂದ್ರೆ, ಇ ಮಸ್ಟ್ ಲೈಸ್ ಬಿಟ್ವೀನ್ 1 and 5 of n ಟೋಷನ್. ಸೊ ಅದು ಇ ಹೇಗಿರ್ಬೇಕು ಅಂದ್ರೆ, ಫಸ್ಟ್ ನಾವು ಲಾರ್ಜ್ ನಂಬರ್ ತಗೋಬೇಕು. ಮೀನ್ಸ್ ವಾಟ್, GCD ಆಫ್ 5n and e ಮಸ್ಟ್ ಬಿ 1 ಅಂದ್ರೆ ಏನು, ದೇ ಆರ್ ರಿಲೇಟಿವ್ಲಿ ಪ್ರೈಮ್ ಇರಬೇಕು. ಇನ ನಾವು ಈ 1 ಮತ್ತೆ 5 ಆಫ್ n ಮಿಡ್ಲ್ ಇರುವಂತ ಯಾವುದೇ ವ್ಯಾಲ್ಯೂ ಅಲ್ಲಿ ತಗೋಬೇಕು, ಬಟ್ ಅದು ರಿಲೇಟಿವ್ಲಿ ಪ್ರೈಮ್ ಇರಬೇಕು ಇದಕ್ಕೆ, ಅಥವಾ ಇವೆರಡರದ್ದು GCD 1 ಬರ್ಬೇಕು ಅಂತ ನಂಬರ್ ಅನ್ನ ನಾವು ಚೂಸ್ ಮಾಡ್ಬೇಕು. ಒನ್ಸ್ ಯು ಚೂಸ್ ಇ, ನೆಕ್ಸ್ಟ್ ಸ್ಟೆಪ್ ವಿ ಹ್ಯಾವ್ ಟು ಕಂಪ್ಯೂಟ್ ಪಿ ಕ್ಯೂ ಅಂಡ್ ಅ ಪ್ರೈವೇಟ್ ಎಕ್ಸ್ಪೋನೆಂಟ್ ಡಿ. ಸೊ ಈ ನ ಮತ್ತೆ ಟೋಷನ್ ಫಂಕ್ಷನ್ ಅನ್ನ ಯೂಸ್ ಮಾಡಿ ನಾವು ಏನ್ ಮಾಡ್ತೀವಿ, ಪ್ರೈವೇಟ್ ಕೀಗೆ ಏನ್ ಬೇಕು ಡಿ ಅದನ್ನ ಫೈಂಡ್ ಔಟ್ ಮಾಡ್ತೀವಿ. ಡಿ ಅಂದ್ರೆ ಏನು, ಇ ಇನ್ವರ್ಸ್ ಮಾಡ್ ಆಫ್ phi of n, or you can write it as ED is congruent to 1 mod phi of n. ಇದು ED. Once you get D, then ಇವಾಗ ನಿಮಗೆ ಪ್ರೈವೇಟ್ ಕೀಸ್ ಸಿಕ್ತು. ಪ್ರೈವೇಟ್ ಕೀಸ್ ಏನು, ಪ್ರೈವೇಟ್ ಕೀಸ್ ಆರ್ ಇಂಡಿಕೇಟೆಡ್ ಬೈ ದ ಪೇರ್ n, d. n ಏನು, n is obtained by product of p and q, two large prime numbers. Understood? n ಆದ್ಮೇಲೆ d ತಗೋಬೇಕು. d ಹೇಗೆ ಫೈಂಡ್ ಔಟ್ ಮಾಡ್ತೀರಿ, d ಫೈಂಡ್ ಔಟ್ ಮಾಡ್ಬೇಕಂದ್ರೆ we want ಟೋಷನ್ ಫಂಕ್ಷನ್ and e. Understood? ಟೋಷನ್ ಫಂಕ್ಷನ್ e ಎರಡನ್ನು ಯೂಸ್ ಮಾಡಿ we define d. Once you find d, pair the n, d is what, it's a private key. ಇದು ಪ್ರೈವೇಟ್ ಕೀ ನ ರಿಪ್ರೆಸೆಂಟ್ ಮಾಡ್ತಾವ. ಇವು ಏನಿರ್ತಾವು, these are all numbers only. Okay. After that, public keys are indicated by pair n, e. ಈ ಏನ್ ಮಾಡಿರ್ತಿರಲ್ಲ, ತಗೊಂಡಿರ್ತಿರಲ್ಲ, ಆ e ಮತ್ತೆ n, these two numbers, this pair gives you public key. After this, ಎನ್ಕ್ರಿಪ್ಷನ್ ಮಾಡಬೇಕು ಅಂದ್ರೆ, ಎನ್ಕ್ರಿಪ್ಷನ್ ಮಾಡಕ್ ಇಲ್ಲಿ ಎನ್ಕ್ರಿಪ್ಷನ್ ಅಲ್ಲಿ ನಾವು ನೋಟೇಶನ್ ಒಂದು ಸಿ ಅಂತ ಯೂಸ್ ಮಾಡ್ತೀವಿ, ಅದಕ್ಕೆ ನಾವು ಸಿಫರ್ ಟೆಕ್ಸ್ಟ್ ಅಂತ ಕರಿತೀವಿ. ಸೊ ಎನ್ಕ್ರಿಪ್ಷನ್ ಫಾರ್ಮುಲಾ ಏನು, ಸಿ ಇಸ್ ಈಕ್ವಲ್ ಟು m raised to e mod n. ಓಕೆ, ಇಲ್ಲಿ m ಅಂದ್ರೆ ಏನು, m is called as a plain text, c is cipher text, m is called as plain text. e ಮತ್ತೆ n ಆಲ್ರೆಡಿ ನೀವು ಫೈಂಡ್ ಔಟ್ ಮಾಡಿರ್ತೀರಿ. ಓಕೆ, ನಾವು ಡಿಕ್ರಿಪ್ಷನ್, decryption, as I said, M is plain text and M must be less than N. Okay, M is denoted by M is equal to C raised to D into mod N. C C equal to M raised to E mod N ಇದನ್ನ M is equal to C raised to D mod N ಇದನ್ನ ನೀವು vice versa encryption ಇಂದ decryption ಇಂದ encryption find ಮಾಡ್ಕೋಬಹುದು. So these are the steps to generate the keys, public key and private key. Okay, one more time I will recall you. Public key ಏನು, public key N, E, private key ಏನು N, D. Okay, ಅವನು find out ಮಾಡ್ಬೇಕಂದ್ರೆ first what is the procedure step? First step to choose P and Q large prime numbers, then product N ಸಿಗುತ್ತೆ. Later we have to choose torsion function, then between 1 to torsion function we have to choose E. Okay, that should be relatively prime to your torsion function. Okay, ಇದೆಲ್ಲ steps ನೀವು example ಮಾಡಿದ್ವಿ ಅಂದ್ರೆ ಅದಕ್ಕೆ ನಿಮ್ಗೆ you can understand very easily. We'll take one example. Consider an example. Question is, using RSA algorithm, find public key and private key with respect to P equal to 3, Q equal to 11 and M equal to 31. Okay, ಇಲ್ಲಿ ಏನ್ ಮಾಡ್ಬೇಕು ನಾವು, ಕ್ವಶನ್ ಏನು, ಪಬ್ಲಿಕ್ ಕೀ ಮತ್ತೆ ಪ್ರೈವೇಟ್ ಕೀನ ಫೈಂಡ್ ಔಟ್ ಮಾಡ್ಬೇಕು ಅಷ್ಟೇ. ನಿಮಗೆ ಪಿ ಕೊಟ್ಟಿದ್ದಾರೆ, ಕ್ಯೂ ಕೊಟ್ಟಿದ್ದಾರೆ, ಎಂ ಕೊಟ್ಟಿದ್ದಾರೆ. ಮೀನ್ಸ್ ಪಿ ಅಂಡ್ ಕ್ಯೂ ಪ್ರೈಮ್ ನಂಬರ್ಸ್, ಎಂ ಅಂದ್ರೆ ಪ್ಲೇನ್ ಟೆಕ್ಸ್ಟ್. ಓಕೆ, ಬೈ ಡೇಟಾ is 3, Q is 11 and M is 31. What is the first step? First step P and Q already ಕೊಟ್ಟಿದ್ದಾರೆ. What is the next step? Next step is to find N. What is N? N is P into Q. So P into Q is 3 into 11, that is 33. Okay, we have got N as 33. N 33 ಸಿಕ್ತು. ನೆಕ್ಸ್ಟ್ ಏನ್ ಮಾಡಬೇಕು, ಟೋಷನ್ ಫಂಕ್ಷನ್ ಅಲ್ವಾ, and phi of N. So phi of 33. ಟೋಷನ್ ಫಂಕ್ಷನ್ ಹೆಂಗ್ ಮಾಡ್ತೀರಿ, phi of 33, what is the formula? It is P minus 1 into Q minus 1. P minus 1 ಏನು, P3 ಅದ, 3 minus 1 ಅಂದ್ರೆ ಏನು, 2. If you want, I will write one more step, 11 minus 1. So what it gives, phi of 33 is equal to 2 into 10, that is 20. Okay, we have got phi of 33 as 20. Torsion function ಏನು ಸಿಕ್ತು, 20. Now what is the next step after getting phi of n? Next step is to choose E, alva. So now how we have to choose E? We have to choose E between 1 to 20 and that must be little bit larger prime number. Okay, so let between 1 to 20 I am choosing E as 7, as 7 lies between 1 to 20 and 7 and 20 are relatively prime. Okay, their GCD must be 1. This condition must hold. Okay, their GCD must be 1. Now once you get found E, our work is to find D. So D is equal to E inverse mod phi of n, or else you can use ED is congruent to 1 mod phi of n, any of the formula. So now I have E as 7. E ಅಂದ್ರೆ ನಾನು 7 ತಗೊಂಡಿದ್ದೀನಿ. 7 into D is congruent to 1 mod. What is your phi of n? Phi of n is sorry, phi of n is 20. Mod 20. Now what is D? D ಯಾವ ನಂಬರ್ ತಗೊಂಡ್ರೆ ನಿಮಗೆ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿ 7 ಜೊತೆ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿ 20 ಲ ಡಿವೈಡ್ ಮಾಡಿದಾಗ ರಿಮೈಂಡರ್ 1 ಬರುತ್ತೆ ಅಂತ. ಸಿಂಪಲ್. ಇದು ಇನ್ವರ್ಸ್ ಆಫ್ 7 ಅಂತ. 7 ಇನ್ವರ್ಸ್ ಹೇಗೆ ಫೈಂಡ್ ಔಟ್ ಮಾಡ್ತಿದ್ರಿ, ಇನ್ ಪ್ರೀವಿಯಸ್ ವಿಡಿಯೋಸ್ I have shown you how to find the inverse ಅಲ್ವಾ. ಸೊ ಡಿ ಅಂದ್ರೆ ಏನೀಗ ಯಾವ ನಂಬರ್ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿದ್ರೆ ನಿಮಗೆ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿದ್ಮೇಲೆ 20 ಲ ಡಿವೈಡ್ ಮಾಡಿದಾಗ ನಿಮಗೆ ರಿಮೈಂಡರ್ 1 ಬರುತ್ತೆ. ಸಿಂಪಲ್ 1 2 3 4 ಹಾಕೊಂಡು ಹೋಗಬೇಕು. ಸೊ ಇಲ್ಲಿ when you put 3 you will get 21. When it is divided by 20 remainder will be 1. So what therefore what you can write? You can write D as 3. Okay, D as 3. So since E is equal to 7, D is equal to 3, both we get, then public key is what? Public key is equal to, it is a pair n comma e, that is n is 33 comma 7, and private key is, it is a pair n comma d, so it is 33 comma 3. Okay, so now you have got private key and public key. Okay, now we'll check for this what is encryption and decryption. Okay, for this example only here we'll check what is encryption. So encryption is what? In encryption, what is the formula? It is C is equal to m raised to e into mod n. Okay, now C is equal to m is given as 31, as is 31, e already we found it as 7, mod n is 33. Okay, if you want you can write, because m is 31, it is a byte data. Okay, now I want to simplify this. So for that we'll take 31. Okay, when 31 is divided by 33, so what will you get? Minus 2 mod 33. Okay, now I want 31 raised to 7, so is congruent to minus 2 raised to 7 mod 33. So what it gives you? 31 raised to 7 minus 2 raised to 7 is what? Minus 128 mod 33. So now divide 128 by 33. Okay, what will you get? Divide 128 by 33. Okay, 33 into 3 is 99. So we will left out with 29. Okay, now we have minus 128. So here 29. So you can use 29, or else in place of 29, 33 minus 29. You can write it as minus 4. Okay, we use minimum number. 31 raised to 7 congruent to, already you have minus, in place of 128 you can write minus 4 mod 33. ಇದು ನಿಮಗೆ previous videos ದಲ್ಲೆಲ್ಲ explain ಮಾಡಿದ್ದೇನೆ ಹೇಗೆ ಅಂತ ಹೇಳಿ. So what it implies? 31 raised to 7 is congruent to 4 mod 33. So what it implies? 4 mod 33 ಅಂದ್ರೆ ಏನಿದೆ? ಇವಾಗ ನಿಮ್ದು C ಅಂದ್ರೆ ಏನು? Then substitute there. C is equal to 0 4 ಅಂತ. ಓಕೆ, 0 4. ಯೂಶಲಿ ನಾವು ಸಿಂಗಲ್ ನಂಬರ್ ಬರಿಬಾರ್ದು. ಇಲ್ಲಿ RSA ಅಲ್ಗಾರಿದಮ್ ಇನ್ ಕ್ರಿಪ್ಟೋಗ್ರಫಿ ನಾವು ಇದನ್ನ 0 4 ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡ್ತೀವಿ. ಏಕೆಂದ್ರೆ ಲೆಟರ್ಸ್ ಏನು ಅಲ್ಫಾಬೆಟ್ಸ್ ಇದಾವಲ್ಲ, A to Z, A B C D ಅಪ್ ಟು Z, ನಾವ್ ಹೆಂಗ್ ತಗೋತೀವಿ ಅಂತಂದ್ರೆ ಇಟ್ ಸ್ಟಾರ್ಟ್ಸ್ ಫ್ರಮ್ 0 0 1 2 3. ಓಕೆ, ಲೈಕ್ ದಿಸ್. ನಾವು C is equal to 0 4 ಅಂದ್ರೆ ಏನು? 0 ಅಂದ್ರೆ A, 4 ಅಂದ್ರೆ E, C ಅಂದ್ರೆ A, and M is what? M is 31. 31 ಅಂದ್ರೆ 3 ಅಂದ್ರೆ D, 1 ಅಂದ್ರೆ B. ಓಕೆ, ಇದೇನು This is a plain text and ಇದು ciphertext. Okay. ಇದು encryption. Next decryption. Decryption ಹೆಂಗ್ ಮಾಡೋದು? Decryption formula ಏನು? M is equal to C raised to D mod N. Okay. Then M is equal to C n ಬಂತು 4, D n is a 3, mod N ಏನು? N is 33. So M here 4 cube. 4 cube is what? 4 cube is congruent to 64 mod 33. We are simplifying this part. Okay. Now 64 congruent to this one is what? When you divide this 64 by 33, what is the LC? The remainder? Remainder is I think 31. It is 31. So we can write M as equal to 31 mod 33. Okay. Therefore, what is M? M is 31. It is dB. Okay. Already we have got this. We know M is 31. So your answer is correct. This is how to find the public key, private key, and find the encryption and decryption of the given values for using the RSA algorithm. Okay. We'll see one more example. Next example is in RSA algorithm, if P is 7, Q is 11 and E is 13, then what will be the value of D? Okay. They asked you to find the value of D. D is what? D comes under what? D comes under private key. Okay. So, what are given by data? E is 7, Q is 11 and E is 13. Okay. Once you know P, we can find P into Q as 7 into 11, that is 77. So, N is 77. Then phi of N is what? P minus 1 into Q minus 1. So, phi of 77 is equal to 7 minus 1 minus 11 minus 1. 7 minus 1 is 6, 11 minus 1 is 10. So, it is 60. Okay. Now, so given E is 13. So, now we have to check whether E lies between 1 to 60, your phi of N. So, S obviously it lies between 1 to 60 and we have to check the GCD of 13 and 60 is 1 S. They are relatively prime. Once this property holds, next our aim is to find D. To find D, what is the formula? D is equal to E inverse mod phi of N. Okay. Now, or else you can write it as E into D is congruent to 1 mod phi of N. Now, you are given as E. E is 13. So, 13D is congruent to 1 mod phi of N. Phi of N is what? Phi of N is 60. Okay. Now, you need to find such a D, that is the inverse of 13, so that whenever it is divided by 60, you should get a remainder as 1. Or else, it is a bit difficult to find by inspection method. In such case, what we need to do? Already I have explained you. This can be written as 13D is equal to 60K plus 1 or D can be written as 60k plus 1 divided by 13. Now put k value so that it is divisible by 13. Okay. Again, if I put k as 8, then we will get to D as 37. Okay. Therefore, public key public key is what? E comma n is what? E is 13, n is 77. N is 77. Then private key is D comma n. D is what? What we have got now, 37 and 77. Okay. This is how we found D. Okay. In the next video, I am going to solve some other examples on RSA algorithm. Keep practicing all these examples. These are all important examples. If you have any doubts, do comment in the comment box. In the next video, I am going to discuss other 3 examples. Till then, take care. If you are not yet subscribed my channel, do subscribe. Thank you.